Okay, so for question 1, we have f of x is equal to x to the power of 3 plus 2x squared minus 8x plus 5. And for part A, for 2 marks, we need to find f dash dash of x. So if you don't know, I've made videos on all of the Edexcel A-level maths content, and any particular videos that are relevant for a question, I'll link them in the description. So this question is to do with year 1 differentiation, because we just need to differentiate this polynomial here. So to find f dash dash of x, so firstly we need to find f dash of x, so we need to differentiate this here. So if we do it term by term, so if you differentiate x to the power of 3, this will be 3x squared, and then it's going to be plus this 2 here, and if you differentiate x squared, it's equal to 2x, and then this minus 8x, when you differentiate it, is just going to be minus 8, and then this plus 5 is just going to go away because it's a constant. So therefore this f dash of x is equal to 3x squared, and then 2 times 2 is 4, so this is 4x, and then minus 8, like this here. So therefore to find f dash dash of x, we're just going to differentiate this again. So if we differentiate 3x squared, so it's going to be 3 times, and then x squared differentiated is 2x, and then it's just going to be plus 4, and then this minus 8 is going to go away. So this is going to be equal to 3 times 2, which is 6, so it's going to be 6x plus 4. So f dash dash of x is equal to 6x plus 4. You get 1 mark for attempting to differentiate to find f dash dash of x, and you get another mark for getting this 6x plus 4. Okay, and then for the first part of B, we need to solve f dash dash of x is equal to 0. So therefore, we're going to say that this 6x plus 4 is equal to 0. Move this 4 onto the other side, so we get 6x is equal to minus 4, and then divide both sides by 6, so we get x is equal to minus 2 over 3. So this is x when f dash dash of x is equal to 0, and this is worth 1 mark. Okay, and then for the second part of B, we need to find the range of values of x for which f of x is concave. Now, this is to do with how we use second derivatives. Remember that f of x is concave when f dash dash of x is less than 0. So therefore, as we figured out in part A, that f dash dash of x is 6x plus 4, we're going to set this 6x plus 4 less than 0 like this here, and then if we rearrange it in the same way that we did in the first part of B, we would get that x is less than minus 2 over 3. So therefore this is the answer. F of x is concave when x is less than minus 2 over 3, and this will get you 1 mark. Okay, so for question 2, we're told about a sequence that is defined by u1 is equal to 35 and un plus 1 is equal to un plus 7 cos n pi over 2 minus 5 and then minus 1 to the power of n. And for the first part of A, we need to show that u2 is equal to 40. So this is a recurrence relations question. So remember, the way that recurrence relations work is the next term in the sequence is defined by the previous term in the sequence. So we're trying to find u2 and we're given u1. So what we're going to do is we're going to sub u1 into this expression here in order to get out u2. Okay, so u2 is going to be equal to, so it's un, so here un is going to be u1, so this is 35, so it's 35 and then it's plus 7 cos. Now here we have n. Now as we've subbed in for un here, we've subbed in u1, therefore here n is equal to 1. Be careful with this, don't make the mistake of thinking n is equal to 2. N is equal to 1 because un here that we've subbed in is u1. So therefore n is equal to 1, so this is going to be 1, which is n, and this is multiplied by pi, and this is over 2, and then minus 5, and then minus 1 to the power, and it's going to be to the power of 1, like this here. So therefore u2, if you put this into your calculator, is equal to 40, which is what's required. So this gives you 1 mark. Okay, and then for the second part of A, we need to find the value of u3 and the value of u4. So this is the exact same thing. We're now just trying to find the third term and the fourth term in the sequence. So if we start with u3. So now we're going to sub in u2, which is 40, into this. So it's going to be 40 and then plus 7 cos. And okay, so now n, because we've subbed in u2, now n is going to be equal to 2. So this is going to be 2 times pi over 2 minus 5 and then minus 1. That's going to be to the power of 2. And if you put this into your calculator, you get a value of 28. So now if we're trying to find u4, we're going to sub u3 into this here. So u3 is 28, and that's going to be plus 7 cos. So now n is going to be 3, so it's 3 times pi over 2 minus 5 and then minus 1 to the power of 3. So if you put this into your calculator, this is equal to 33. So to get the 2 marks here, you get 1 mark for finding u3 and 1 mark for u4. Okay, and then for part B, we're told that the sequence is periodic with order 4, and for the first part of B, we need to write down the value of U5. Now, order 4, if it's periodic with order 4, this means that after every 4 terms, it repeats itself, okay? So U1 is equal to 35, U2 is equal to 40, U3 is equal to 28, and U4 is equal to 33. So these are 4 terms, and then after this, it's just going to repeat itself. So that means that U5 is going to be equal to U1 because it's going to start repeating itself. So therefore, this is equal to 35. So U5 is equal to 35. Okay, and then for the second part of B, we need to find the value of this sigma here, where it starts with r is equal to 1, and then it goes up till 25, and this is for UR. So this is a sigma notation question, and what this sigma notation is saying, so UR and then starting with r is equal to 1, so it's starting with U1, and then it's going to be plus U2 plus U3 plus U4, and then so on all the way up to U25. So we need to find what all of these terms added together are. So how do we do this? Well, the way that we're going to do this is by using the fact that it's periodic with order 4. So remember, the first 4 terms are 35, 40, 28, and 33. So therefore, U1 plus U2 plus U3 plus U4 is equal to 35 plus 40 plus 28 plus 33, which if you put this into your calculator is equal to 136. So this is the first 4 terms added together. But remember that this is periodic and it keeps repeating this, right? So if we're going up to U25, so the term before U25 is U24. 24 divided by 4 is 6. So up to U24, this here, this U1 plus U2 plus U3 plus U4, is just going to repeat itself 6 times. So therefore, we're just going to find U1 plus U2 plus U3 all the way up to U24. This is going to be 6 times 136 because it's this 4 times, which if you put this into your calculator is equal to 816. So therefore, U1 plus U2 plus U3 and then so on plus U24 plus U25 is going to be, so up to 24 we found it's 816, and then U25 is going to repeat itself, so U25 is going to be equal to U1, and U1 is 35, so U25 is going to be 35. So it's going to be 816 plus 35, which if you put this into your calculator is equal to 851. So this is the answer to this sigma here. U1 plus U2 plus U3 all the way up to U25 is 851. To get the 2 marks here, sorry, you get 1 mark for using a correct method in order to add these terms together, and you get another mark for getting the answer as 851. Okay, so for question 3, we're given that log base 2 of x plus 3 plus log base 2 of x plus 10 is equal to 2 plus 2 log base 2 of x. And for part A, we need to show that this here is true for 3 marks. So this is a logarithm equation. And the best way to deal with an equation like this and getting it into this form is on both sides of this equation, get everything into a single log of base 2, and then when you do that you can kind of cancel out the log base 2 and you're just left with the x terms. So if we focus on this side here first, we want to get everything into one log. We have this log base 2 of this plus this log base 2 of this. Remember, when you have two logs that are adding together, you can combine them into one log by multiplying what is inside the log functions. So we can write this as log base 2 of x plus 3 multiplied by x plus 10, like this here, because we've got these two logs added together. And then this is going to be equal to 2 plus, so we have this 2 log base 2 of x. Remember, when you have a coefficient in front of a log, you can bring it into the log as a power. So we can write this as log base 2 of x squared, like this here. Okay, so this side we've got it all into one log, so this is fine. On this side we need to get all of this 2 plus log base 2 of x squared, into one log. Now 2 here, we need to write this as log base 2 in order to combine this with this log here. Now remember what log base 2 actually means. So let's say that we have log base 2 of, let's call it a, is equal to 2. What this is actually saying is 2 to the power of 2 is equal to a. Well, 2 to the power of 2 is equal to 4, so 4 is equal to a. So 2, we can write this as log base 2 of 4. So therefore, if we rewrite this equation up here, it's log base 2 of x plus 3 x plus 10 is equal to log base 2 of 4 plus log base 2 of x squared. Now we can simplify this because we have log base 2 of x plus 3 x plus 10, and this is equal to, so we have log base 2 4 plus log base 2 x squared, so we can combine these two logs as they're adding together. We can combine the two logs by multiplying what is inside the log, so it's going to be log base 2 of 4 times x squared, so this is going to be 4 x squared. And now we have log base 2 of this is equal to log base 2 of this. So essentially what we can just do now is get rid of these log base 2's and write this as x plus 3 x plus 10 is equal to 4 x squared. If we expand this bracket here, it's going to be x squared plus 3x plus 10x plus 30 is equal to 4x squared. If we bring this 4x squared onto this side of the equation, so it's going to become x squared minus 4x squared, which is going to be minus 3x squared. We have 3x plus 10x, which is equal to 13 x, and then plus 30, and this is equal to 0. Now we need to show that this is equal to this here. This and this are identical, except here we've got minus 3, whereas here we've got 3, and then here we've got minus 13 and minus 30, here we've got plus 13 and plus 30. So if we just multiply everything by minus 1 here, we get 3x squared minus 13x minus 30 is equal to 0. And this is what's required here. In order to get the 3 marks here, you get 1 mark for combining this x plus 3 and x plus 10 in the log, like this here. You get another mark for getting rid of the logs here and writing this x plus 3, x plus 10 is equal to 4x squared, and you get a final mark for showing it's equal to this here. Okay, and then for the first part of B, we need to write down the roots of the equation that we found, this quadratic, in part A. So we need to factorize this here. So we're going to have two brackets, and this is equal to 0. One of them is going to have 3x here, and the other one is going to have x. And you find that if you make this plus 5 and this minus 6, 5 times minus 6 is equal to minus 30, and then x times 5 is equal to 5x, and 3x times minus 6 is equal to minus 18x. And when you add these together, it's equal to minus 13x. So this is the equation factorised. So this means that either 3x plus 5 is equal to 0, or x minus 6 is equal to 0. So that means that 3x is equal to minus 5, sorry. So therefore x is equal to minus 5 over 3. If x minus 6 is equal to 0, this means that x is equal to 6. So these are the two roots to this equation here. X is equal to 6 and x is equal to minus 5 over 3. This is 1 mark. Okay, and then for the second part of B, we need to state which of the roots in part BI is not a solution of this original equation up here. We need to give a reason for our answer. Now, the answer to this is where x is equal to minus 5 over 3. X cannot be equal to minus 5 over 3. The reason for this is if you look at this equation up here, if x is equal to minus 5 over 3, if you sub x into this here, this 2 log base 2 of x, this will become log base 2 of minus 5 over 3, which you can't have. You can't log a negative number, so therefore this is not a solution. So therefore x cannot be equal to minus 5 over 3. It says it wants us to give a reason for our answer. Say something like x cannot be equal to minus 5 over 3 because log base 2 of x would be equal to log base 2 of minus 5 over 3, and you can't log a negative number. A reason like that would give you the 1 mark. Okay, so for question 4, we're told that coffee is poured into a cup, and the temperature of the coffee, which is H degrees Celsius, T minutes after being poured into the cup, is modelled by this equation here, where H is equal to AE to the power of minus BT plus 30, where A and B are constants. And we're told that initially the temperature of the coffee was 85 degrees Celsius, and for part A, for 1 mark, we need to state the value of A. So this is a question on exponential modelling. So the key to this question part A is this line here, where we're told initially the temperature of the coffee was 85 degrees Celsius. Now, whenever you see the word initially, you need to think that T is equal to 0. That's what this means. And we're told that the temperature of the coffee was 85 degrees Celsius. So here H is equal to 85. So therefore, to find the value of A, we're going to sub in these values into this equation here. H is equal to 85 and T is equal to 0. So it's going to be H, which is 85, is equal to AE to the power of minus B, and then instead of T here, it's 0, and then plus 30. So this b times 0, this minus b times 0 will be 0, so this is going to be e to the power of 0. Remember, e to the power of 0 is 1, so this is just going to be a here, a times 1, so it's just going to be a, and then plus 30, and then remove this 30 to the other side, we get that 55 is equal to a. So this is the value of a, and that's how you get the 1 mark. Okay, and then for part B, we're told initially the coffee was cooling at a rate of 7.5 degrees Celsius per minute, and we need to find a complete equation linking H and T, given the value of B, to 3 decimal places for 3 marks. So essentially what we just need to do here is find B. Okay, so the key to this is this line here. So we're told initially, so again, whenever you see initially, T is equal to 0. The coffee was cooling at a rate of 7.5 degrees Celsius per minute. Now, as it's talking about rate, this is talking about the derivative. So therefore here, dH over dt is equal to 7.5. However, it's talking about that the coffee was cooling, so that means the temperature was decreasing. So therefore, this rate is going to be negative. So therefore, dH over dt is going to be equal to minus 7.5. So what we can do is, as dH over dt is equal to minus 7.5, when t is equal to 0, we can use this in order to find b, okay? So firstly, let's find dh over dt. So we're going to differentiate this here. We found in part A that a is equal to 55. So if we differentiate this, it's going to be dh over dt is equal to, so if we differentiate this, it's going to be 55 multiplied by, and then we're differentiating e to the power of minus bt. Minus b is a constant, so therefore it's going to come down, so it's going to be minus b, so it's going to be a coefficient, and then e to the power of minus bt, and then we're no longer going to have this 30 on the end like this here because it's a constant, and therefore dh over dt is going to be equal to minus 55b e to the power of minus bt. So therefore we can sub in the value of dh over dt, and t is equal to 0, dh over dt is equal to minus 7.5. So it's going to be minus 7.5 is equal to minus 55b e to the power of minus b, and t is 0. This is the same as before. Minus b times 0 is 0, so this is going to be e to the power of 0, which is 1. So this is just going to be minus 7.5 is equal to minus 55b here, and then divide both sides by minus 55, so we get b is equal to, if you put it into your calculator, is equal to 3 over 22. The question asks us to give the value of b to 3 decimal places, which is 0.136. So therefore the complete equation, if we sub in the value of a and b, it's going to be h is equal to a, which is 55, and then it's e to the power of minus b, so this is minus 0.136 t, and then plus 30. So in order to get the marks here, you get 1 mark for differentiating dh over dt into this format here. You get another mark for subbing in the 0 and the minus 7.5 and rearranging it like this here, and then you get another mark for getting the complete equation. Okay, so for question 5, we're told that the curve C has equation y is equal to f of x, and we're told that the curve passes through the point P, which is 3 minus 10, and we're told it has a turning point at P. And given that dy over dx is equal to 2x to the power of 3 minus 9x squared plus 5x plus k, where k is a constant, for part A, for 2 marks, we need to show that k is equal to 12. So the way that we can do this is we're told that the curve has a turning point at this point P. And if you remember a feature of turning points as stationary points, turning points exist where dy over dx is equal to 0. Well, we know that this point P has an x coordinate of 3. So therefore what we can do is we can sub in x is equal to 3 for these x coordinates here, and equal this to 0, because dy over dx is equal to 0 where x is equal to 3, and we can rearrange in order to find k. So what we can say is that dy over dx, which is 0, is equal to 2, and then instead of x here we have 3, so it's going to be 3 cubed, and then minus 9 3 squared plus 5 3 plus k. And then let's rearrange in order to find k. So this 2 3 to the power of 3 minus 9 3 to the power of 2 plus 5 times 3. If you put this into your calculator, you get out a value of minus 12, and then it's this plus k on the end like this here, and then move this minus 12 to the other side, so you get that 12 is equal to k, which is what's required. In order to get the 2 marks here, you get 1 mark for subbing in this x is equal to 3 like this here and rearranging, and you get another mark for getting that k is equal to 12. Okay, and then for part B, we need to find the coordinates of the point where C crosses the y-axis for 3 marks, okay? So this is the y-intercept, and the only way that we can find the y-intercept is by finding the original equation y is equal to f of x. We can't do this using dy over dx. So what we need to do is we need to integrate dy over dx in order to get the original equation for y. Okay, so this is just year 1 integration because we're integrating this here. So we're going to integrate this 2x to the power of 3 minus 9x squared plus 5x. We figured out in part A that k is 12, and then dx like this here. Okay, so if we integrate this, this is going to be equal to 2, and then if you integrate x to the power of 3, this is equal to 1 over 4, x to the power of 4, and then it's minus 9 multiplied by, and if you integrate x squared, this is equal to 1 over 3, x to the power of 3, and then it's plus 5 multiplied, if you integrate x, is equal to half x squared, and then plus, and then if you integrate 12, it's going to be 12x, and then remember the plus c on the end. So therefore y is going to be equal to 2 times a quarter is a half, so it's going to be a half x to the power of 4 minus, and then 9 times a third is 3, so it's going to be 3x to the power of 3, and then it's going to be plus 5 over 2 x squared, and then plus 12 x plus c. So this is an equation for y. Now we need to find this plus c on the end. And the way that we can do this is we know a point on the curve. We know that the point P is 3 minus 10. So we're going to sub this in, x is equal to 3 and y is equal to minus 10 into this equation here. So it's going to be minus 10 is equal to half, and then this is 3 to the power of 4 minus 3, and then 3 to the power of 3 plus 5 over 2, 3 squared plus 12 times 3, and then this plus c on the end, okay? So you've got minus 10 is equal to, so all of this stuff here, if you put this into your calculator, is equal to 18, and then we've still got this plus c on the end, and then move this 18 to the other side, so we get that c is equal to minus 28. So therefore, if we write out this full equation, it's going to be y is equal to a half x to the power of 4 minus 3x to the power of 3 plus 5 over 2x squared plus 12x minus 28. So we need to find the y-intercept here. Well, with polynomials like this is a quartic, this polynomial, the y-intercept is just going to be this constant at the end. So therefore the y-intercept is equal to minus 28, or this coordinate is going to be 0 minus 28, and then this here is the final answer. In order to get the 3 marks here, you get 1 mark for integrating this dy over dx here, like this. You get another mark for subbing in this x is equal to 3 and y is equal to minus 10, and you get another mark for finding the y-intercept as minus 28. Okay, so for question 6, we're told about the position vectors of the points A, B, C, and D. And for part A, we need to show that AD is parallel to BC for 2 marks. So this is a year 1 vectors question because it's to do with 2D vectors. Now, in order to show that the vectors AD and BC are parallel, we need to show that these vectors are multiples of each other. In other words, we need to show that the vector BC is equal to some sort of scalar, which we'll call lambda, of AD, where lambda is a constant, so therefore AD is a multiple of BC. So in order to prove this here, we firstly need to find the vectors AD and BC. So let's start with the vector AD. So we're given the position vectors of points A and D. Remember what a position vector is. If we're talking about the position vector of point A, this is going to be the vector OA, where O is the origin. So I think it's best for questions like this to draw a quick diagram. So if we draw axes, say this is Y and this is X and this is the origin, let's say that point A is here, and let's say that point D is here. So the vector OA is going to be this here, going in this direction, and the vector OD, so the position vector of D, is going to be going in this direction here, okay? So we need to find the vector AD, so going from A to D in this direction here. So the vector AD. So if we do this, so starting from A, if we go down to O in this direction, so this is going to be the vector AO, and then plus, and then if we go in this direction here, so this is going to be the vector OD. Okay, remember that vectors are direction specific, so AO is equal to minus OA, and then plus OD, and we know the vectors OA and OD because we're given them here. So if we sub this in, so it's going to be minus, and then OA, so this is going to be 12I, and then plus OD, so this is this here, this 22I plus 24J. And then if we simplify this, so minus 12I plus 22I is going to be 10I, and then plus 24J. So this here is AD. So now we need to find the vector BC. So we're going to use the exact same formula here, but we're going to sub in B for A and C for D. This is going to be minus OB plus OC. So if we sub these values in, so it's going to be minus, and then OB is 16J, and then plus OC, which is this 50I plus 136J. And then if we sub this, if we simplify this, so it's going to be 50I, and then 136J minus 16J is going to be 120J. So this here is BC. Now we need to prove that these are multiples of each other. So if we look at I and J, so if we start with I, so 50 divided by 10, if you put this in your calculator, obviously just 5, and then it's 120 and 24, 120 over 24 is also equal to 5. So therefore, BC is 5 times bigger than AD. So therefore, as we found that this scalar here is 5, therefore the vectors AD and BC are parallel. In order to get the 2 marks here, you get 1 mark for finding AD and BC, and you get another mark for finding that BC is equal to 5AD. Okay, and then for part B, we're told that the points A, B, C and D are used to model the vertices of a running track in the shape of a quadrilateral. And we're told that runners complete 1 lap by running along all 4 sides of the track, and the length of the sides are measured in meters. And given that a particular runner takes exactly 5 minutes to complete 2 laps, we need to calculate the average speed of this runner, giving our answer in kilometers per hour. So this is worth 4 marks. So this is using vectors in a modelling sense. Okay, so we're told about speed. Now remember the formula for speed. Speed is equal to distance over time. So we need to find the distance and the time in order to find the speed. Okay, so let's start with the distance. So we're told that this runner completes 2 laps. Now 1 lap is completed by running along all 4 sides of the track. So let's quickly draw this diagram here. So A, B, C and D are used as the vertices of the running track. So if we say this here is A, this here is B, this here is C, and this here is D. So this is A, this is B, this is C, and this is D. So if we connect these together, this is essentially the running track, and then you complete a lap by essentially going around all of the sides. So in order to find the distance of 1 lap, what we can do is we can find the lengths of all of these sides. And the way that we can do this is if we find the vectors AB, BC, CD, and DA, or AD, as we've already found, if we find all of these vectors and find the magnitudes of them, these will be the lengths of these sides. Okay, so if we do this, so as we found in part A, we've already found AD and BC, so we don't need to find these. So let's first start with AB. So using the same formula as before, this is going to be minus OA plus OB. So OA is this 12I, so it's going to be minus 12I, and then plus OB, which is this 16J, so this is going to be AB. We know BC, so we need to find CD, so CD is going to be equal to minus OC plus OD, so it's going to be minus, and then OC is this 50I plus 136J, so it's going to be 50I plus 136J, and then plus OD, which is this 22i plus 24j. So 22i plus 24j. Remember, this minus needs to be in front of OC, so it's in front of both of this 50i plus 136j. So if we expand this, it's going to be minus 50i minus 136j plus 22i plus 24j, and then we can simplify this, so it's going to be minus 50i plus 22i, which is going to be equal to minus 28i, and then minus 136j plus 24j is going to be minus 112j. Okay, so that's CD. So in order to find the lengths of all of these sides here, we need to find the magnitudes of these vectors. Okay, so let's start with finding the magnitude of AD. Now, we found AD in part A. It's this 10i plus 24j. Remember, in order to find the magnitude of a vector, you square both these numbers here, you add them, and then you square root them. So the magnitude of AD is going to be the square root of 10 squared plus 24 squared, which, if you put this into your calculator, is equal to 26. Now, if we find the magnitude next of CD, so this is this vector here, so it's going to be the square root of minus 28 squared plus minus 112 squared, and if you put this into your calculator, it's equal to 28 root 17. Okay, so if we now find the magnitude of the vector BC. Now, we could do it by using the formula that we did here, but as we were told that BC is equal to 5 times AD, and we figured out the magnitude of AD, which is 26, we can just do 5 times 26 in order to find this magnitude, which is equal to 130. And then if we find the magnitude of AB, so AB is this here, so it's going to be the square roots of minus 12 squared plus 16 squared. And if you put this into your calculator, it's equal to 20. So if we annotate this diagram here, so AD is equal to 26, so this is this side here, and then CD is equal to 28 root 17, so CD is equal to 28 root 17, and then BC is equal to 130, and AB is equal to 20. Okay, so therefore, in order to complete a lap of this track, it's going to be these sides added together. So it's going to be 26 plus 28 root 17 plus 130 plus 20, which, if you put this into your calculator, is equal to 176 plus 28 root 17. So if we figure out the distance that this runner travels, okay, so this is the length of one lap, because this is, remember, to complete one lap you go around all of the sides. However, we're told that this runner completes 2 laps, so therefore it's going to be 2 multiplied by this 176 plus 28 root 17. However, there's an important thing we need to consider here, okay? We are told that the length of the sides are measured in meters. So this number here is in meters. However, we are told that we need to calculate the average speed of this runner, giving our answer in kilometers per hour. Now remember, in order to get from meters to kilometers, you have to divide by 1,000. So at the moment, this is in meters, our answer. So in order to get into kilometers, we need to divide this by 1,000. Okay, if you put this here into your calculator, you get out a number of 0.5829, and then this will now be in kilometers because we've divided it by 1,000, this meters here. Okay, so that's the distance. So now we need to find the time. Okay, so we're told that it takes 5 minutes to complete the 2 laps. Okay, so it's going to be 5, but remember that we want to give our answer in kilometers per hour. We don't want it in minutes, we want it in hours. In order to get from minutes to an hour, you divide by 60, because it's 60 minutes in an hour, so it's going to be 5 divided by 60, which if you put this into your calculator is equal to 1 over 12. So therefore, so this is now in hours, so therefore we've got kilometers and we've got hours here, so therefore to get the speed in kilometers per hour, it's going to be this 0.5829 kilometers divided by this 1 over 12 hours. If you put this into your calculator, you get a value of 6.99, and it's going to be kilometers per hour, and this here is the correct answer. So this question is worth 4 marks. In order to get the 4 marks, you get 2 marks for figuring out the lengths of all of the sides, and then you get another mark for finding the distance and the time here, and you get a 4th mark for getting the final answer as 6.99. Okay, so for question 7, we're told a curve has equation x cubed plus 2xy plus 3y squared is equal to 47. And for part A, we need to find dy over dx in terms of x and y for 4 marks. So we need to differentiate this equation here, and as it involves both x and y terms, we're going to use implicit differentiation for this here. So if we differentiate each term individually, so if we start with this x to the power of 3, if we differentiate this in terms of x, this is just going to be 3x squared. If we then differentiate this 2xy, so it's going to be 2, and then this is going to be multiplied by xy differentiated. Now to differentiate xy, you need to use the product rule on this here. The easiest way to use the product rule, in my opinion, is the product rule is this term differentiated multiplied by this term plus this term differentiated multiplied by this term. So the product rule on xy is going to be this term differentiated, so x differentiated, and x differentiated is just 1, and then this is multiplied by this term, which is y, and then this is plus this term differentiated, so y differentiated, and if we differentiate y implicitly, it's equal to dy over dx, and then this is multiplied by this term, which is x. So if we simplify this, it's going to be this 2 at the front, and then 1 times y is just y, and then this is plus, and then it's going to be x dy over dx, like this here. And if we expand the bracket, it's going to be 2y plus 2x dy over dx. So this is 2xy differentiated, and then if we differentiate 3y squared, it's going to be 3 multiplied by, and then we differentiate y squared. So we talked about in the implicit differentiation video, we differentiate this using the chain rule. If you differentiate y squared, is equal to 2y dy over dx, and 3 times 2 is 6, so this is 6y dy over dx. This is 3y squared differentiated, and then 47, when you differentiate it, as it's just a constant, it will just be 0. So if we add these terms together, it's going to be 3x squared plus 2y plus 2x dy over dx plus 6y dy over dx, and this is equal to 47 differentiated, which is equal to 0. We need to find dy over dx, so we need to make dy over dx the subject. So if we get all of the dy over dx terms onto one side of the equation, so if we move this 3x squared plus 2y onto the other side of the equation, so it's going to be 2x dy over dx plus 6y dy over dx is going to be equal to, and then it's going to be minus 3 squared minus 2y, like this here. If we factorize out dy over dx from this here, so it's going to be dy over dx, and then it's going to be 2x plus 6y. This is equal to minus 3x squared minus 2y. And then if we divide both sides by this 2x plus 6y, so on this side it will just be dy over dx, and this is going to be equal to minus 3x squared minus 2y over 2x plus 6y. We can factorize out minus 1 from the numerator here, so it's a bit neater to write this as minus 3x squared plus 2y over 2x plus 6y. So this is dy over dx here, written in terms of x and y, minus 3x squared plus 2y over 2x plus 6y. This is worth 4 marks. In order to get the 4 marks here, you get 1 mark for getting the 3x squared and the 6y dy over dx. You get another mark for getting this 2y plus 2x dy over dx. You get another mark for getting this equation here and attempting to rearrange to find dy over dx. And you get a final mark for this equation here. Okay, and then for part B, we're told about the point P that has the coordinates minus 2, 5, and this lies on the curve. And we need to find an equation of the normal to the curve at this point P, giving our answer in the form ax plus by plus c is equal to 0, and this is for 3 marks. So we need to find the equation of a normal. So remember what a normal is. So let's say that we have the curve like this here, and let's say that we have the point here. This is the point P. The normal is perpendicular to the curve at this point. Okay, now the normal is a straight line. Remember, the equation of a straight line is y minus y1 is equal to m x minus x1. So in order to use this equation, we need a coordinate on the normal and we need the gradient of the normal. Well, the coordinate on the normal, we can just use this p is equal to minus 2, 5, because the normal passes through this point P. And we can find the gradient because we can find the gradient of the curve at this point P by using our equation for dy over dx. So we can find the gradient m, and therefore the gradient of the normal, as it's perpendicular, remember how perpendicular gradients work, it's going to be minus 1 over m. So this is going to be the gradient of the normal. Okay, so if we figure out the gradient of the curve at this point here, minus 2, 5, so we're going to sub in x is equal to minus 2 and y is equal to 5 into this equation of dy over dx here. So it's going to be dy over dx is equal to minus 3, and then instead of x it's minus 2 squared plus 2, and instead of y it's 5, and this is over 2x, so minus 2 plus 6y, so 6 times 5. And if you put this into your calculator, this is equal to minus 11 over 13. So this is the gradient of the curve at P. So therefore the gradient of the normal is going to be equal to minus 1 over m. It's the negative reciprocal, so minus 1 over m of this is going to be, so this negative sign is going to go away, so it's going to be positive, and then 1 over m, so it's going to be 1 divided by this fraction, so this will flip the fraction, so it's going to be 13 over 11. So this here is the gradient of the normal. So therefore we can use this equation here for the gradient of a straight line. So it's going to be y minus y1. So p again is minus 2, 5. So y1 is going to be 5 is equal to m, and we know the gradient is 13 over 11, and then x minus x1, so x1 is minus 2, so this is going to be plus 2 like this here. We need to get this in the form ax plus by plus c is equal to 0, so we have this 11 denominator, so let's get rid of this here because we need a, b and c to be integers. So it's going to be 11y minus 55 is equal to, and then it's going to be 13 times x, it's going to be 13x, and then 13 times 2, which is going to be 26, like this here. Move this 11y minus 55 onto the other side of the equation, so we get 13x minus 11y, and then this minus 55 onto the other side, so it's going to be 26 plus 55, which is equal to plus 81, and this is equal to 0. So this is the equation of the normal. In order to get the 3 marks here, you get 1 mark for plugging in the values here into dy over dx, you get another mark for getting this equation here, the straight line, and you get another mark for rearranging it into this form here. Okay, so for question 8, part A, we need to express 2 cos theta plus 8 sin theta in the form r cos of theta minus alpha, where r and alpha are constants. Okay, and this is for 3 marks. So this is a question in the style of the simplifying a cos x plus b sin x format. So we need to express this here in this format. I've given you the addition formula for cos of a minus b because it's given to you in the formula booklet, so you have access to it in the exam, and you need it for this question. So this r cos of theta minus alpha, this cos of theta minus alpha, let's use this cos of a minus b formula here. So it's going to be r cos of theta minus alpha is equal to, and we're going to use this formula here where theta is A and alpha is B. So it's going to be R, and then it's going to be cos A, so this is cos theta, and then cos B, so this is cos alpha, plus R, and then sin A, so this is going to be sin theta, and then sin B, so this is going to be sin alpha. So this is equal to 2 cos theta plus 8 sin theta. So 2 cos theta plus 8 sin theta is equal to r. I'm going to write this cos alpha first. So it's going to be r cos alpha cos theta plus r, and again I'm going to write this sin alpha first and then this sin theta. And if you look at this, you can see that we have this cos theta plus sin theta, and here we have this cos theta plus sin theta. So therefore here 2 is equal to r cos alpha, so 2 is equal to r cos alpha, and 8 is equal to r sin alpha, so 8 is equal to r sin alpha, and we can use this in order to find r and alpha. So remember, r is quite simple. R is just these two numbers squared added together and the square root of this, so r is equal to the square root of 2 squared plus 8 squared, which if you put this into your calculator is equal to 2 root 17. So this is r, it wants the exact value of r, so we'll leave it as this here. To find alpha, remember that r sin alpha over r cos alpha, so these r's will cancel out, and sin alpha over cos alpha is equal to tan alpha. So therefore tan alpha is equal to r sin alpha, and r sin alpha is 8, and this is over r cos alpha, and r cos alpha is 2, so this is 8 over 2. Therefore tan alpha is equal to 4, so therefore alpha is equal to the inverse tan of 4, which if you put this into your calculator is equal to 1.326. It says it wants it in radians to 3 decimal places. And this here is the final answer, so therefore we can write this 2 cos theta plus 8 sin theta. We can write this as r, which is 2 root 17, and then cos of theta minus alpha, which is 1.326. This is worth 3 marks. To get the 3 marks, you get 1 mark for figuring out r, you get another mark for figuring out that tan alpha is equal to 8 over 2, and you get another mark for figuring out that alpha is equal to 1.326. Okay, and then for part B, we're told that the first 3 terms of an arithmetic sequence are cos x plus sin x, and cos x plus 2 sin x. And given that S9 represents the sum of the first 9 terms of this sequence, for the first part of B, we need to find the exact maximum value of S9. So this is an arithmetic series question. I've given you the formula here for Sn for arithmetic series because this is given to you in the formula booklet, so you have access to it in the exam. So we need to find S9. So in order to use the formula for Sn here, we need 3 things. We need to know n, we need to know a, and we need to know d, where n is the number of terms in the series, a is the first term, and d is the common difference. Okay, so n is easy because we're trying to find S9 for Sn, so there are 9 terms, therefore n is equal to 9. A is the first term, and we're told that the first term is cos x, so a is cos x, and d is the common difference. If you look at this sequence, the difference between cos x and cos x plus sin x and cos x plus 2 sin x, we keep adding sin x. So therefore the common difference is sin x. So if we sub these values in, so it's going to be S9 is equal to n over 2, so this is going to be 9 over 2, and then 2a, so this is going to be 2 cos x, plus n minus 1, so it's going to be 9 minus 1, which is 8, and then the common difference, which is sin x, okay? The question is asking us to find the exact maximum value of S9. Now, of course, x can take any value, so we need to find the maximum value that this can have. Well, in part A, we showed that 2 cos theta plus 8 sin theta can be written as this here, and this is what we've got here, this 2 cos x plus 8 sin x. We've just got x instead of theta. So, therefore, we can sub out this 2 cos x plus 8 sin x for this here, where x is theta. So, we can write this as S9 is equal to 9 over 2, and then instead of this 2 cos x plus 8 sin x, we can write this as 2 root 17 cos of x minus 1.326, okay? We can simplify this because S9 is going to be equal to, these two will cancel out and just leave us with 9 root 17 cos of x minus 1.326. So why is this useful? Because this is a lot easier to find the maximum value of this. The reason for this is, as we talked about before, it doesn't matter what is inside the trig function. The maximum value of cos, it doesn't matter what is inside it, the maximum value that cos can have is 1. So therefore, if we're trying to find the maximum value of S9 and we're trying to find the maximum value of this cos function, we're just going to sub in 1 here. So therefore, we're going to say that S9 is equal to 9 root 17 multiplied by this max of cos, which is 1, which is going to be equal to 9 root 17. So therefore, S9 is equal to 9 root 17. This is the maximum value. This is worth 2 marks. In order to get the 2 marks, you get 1 mark for realising that the max of cos is 1 here, and we sub this in, you get the second mark for finding that it's 9 root 17. Okay, and then for the second part of B, we need to deduce the smallest positive value of x at which this maximum value of S9 occurs. Now, this maximum value occurs when cos is equal to 1. So what we're going to say is this cos of x minus this 1.326, which is inside this trig function here, this is equal to 1. So essentially we need to find the smallest positive value of x for which this occurs. Well, if you take the inverse cos of 1, this is obviously equal to 0, okay, because where cos 0 is equal to 1. So for what we can say is that x minus 1.326 is equal to 0. Move this this minus 1.326 onto the other side to get that x is equal to 1.326, and this is going to be the smallest positive value of x for which this cos is equal to 1, and therefore for which this maximum occurs, this 9 root 17, and this will get you the mark. Okay, so for question 9, we're told the curve C has parametric equations x is equal to t squared plus 6t minus 16 and y is equal to 6 natural log of t plus 3. And for part A, for 3 marks, we need to show a Cartesian equation for C is y is equal to a natural log of x plus b. Okay, so this is a parametric equations question. Now, in order to get an equation, a Cartesian equation where y is a subject and this is for x, this y parametric equation here, we need to sub out this t here for x terms. So what we need to do with this x parametric equation here, we need to rearrange it to make t the subject, and therefore we can make a substitution for t. Now this here is a quadratic, and therefore the way that we can make t the subject here is by completing the square. So what we can say, so it's x is equal to, so what we can do, we can complete the square on this here. So we have this t squared plus 6t. So to complete the square on this, it's going to be t plus, and then we're going to half this coefficient here. So at the moment it's 6, so it's going to be 3. and then this is going to be this here squared, and then remember we need to take away whatever this number here is squared. So 3 squared is 9, so it's going to be minus 9. So this is the completed square format. Remember we have this minus 16 on the end as well, so this is minus 16. So therefore x is equal to t plus 3 squared, and then minus 9 minus 16 is minus 25. So what we can do, we can rearrange in order to make t the subject here, so move this minus 25 to the other side, so we get that x plus 25 is equal to t plus 3 squared, and then square root both sides. Now I'm going to write this as x plus 25 to the power of half, and this is equal to t plus 3. Now we could move this plus 3 to the other side in order to make t the subject. However, you can actually see that here inside this natural log we have this t plus 3. So therefore we can just sub out this t plus 3 for this x plus 25 to the power of a half. So we can rewrite this here as y is equal to 6 natural log, and then instead of this t plus 3 we can write this x plus 25 to the power of a half, like this here. Now we need to get it into this format here. We don't have this half power, so we need to get rid of this. The way that we can get rid of this is, if you remember your laws of logs, if you have a power inside a log, you can bring it to the front as a coefficient. So we can say that y is equal to this 6 here multiplied by, and then if we bring this half to the front, it's now going to be a half natural log of this x plus 25, and then therefore y is equal to 6 times a half, which is 3, so this is going to be 3 natural log of x plus 25, and this is in the required format, so this is the answer. To get the 3 marks here, you get 1 mark for getting it into this format here, you get another mark for subbing it into y, and then you get the final mark for getting the final answer. Okay, and then for part B, we're told the curve C cuts the y-axis at the point P, and we need to show that the equation of the tangent to C at this point P can be written in this format here, and this is for 4 marks. Okay, so this is a question on the equation of a tangent. Okay, so let's remind ourselves what's going on here. So let's say we have this curve, and we have a tangent at a particular point. Now this point is the point P. Okay, so to find the equation of a tangent, we need to use the equation for a straight line, which is y minus y1 is equal to mx minus x1, like this here. So in order to use this, we need a point on the tangent, and we need the gradient of the tangent. Okay, well, we're told that the equation of the tangent to C is at the point P. Okay, so we can use this coordinate, and we're told that the curve C cuts the y-axis at this point P. Now if it cuts the y-axis, this means that x is equal to 0. So we know the x coordinate of this point P. In order to find the y coordinate, we can just sub in x is equal to 0 into this equation here. So it's going to be y is equal to 3 natural log of an x is 0, so it's going to be plus 25, like this here. So it's going to be y is equal to 3 natural log of 25. So therefore the point P, x is equal to 0 and y is equal to 3 natural log of 25. So we can use this point for the equation of a straight line. Now we need to find the gradient of this straight line. Now remember, the equation the gradient of a tangent is going to be the same as the gradient of the curve at that particular point. Okay, now we can find the gradient of the curve at this point. This is where x is equal to 0, because we have the equation here, the Cartesian equation for y. So we can just differentiate this to find dy over dx, and then sub in x is equal to 0 in order to find the gradient. Okay, so if we differentiate this here, so it's going to be dy over dx is equal to 3. Now this is year 2 differentiation, when you differentiate a natural log. Remember, when you differentiate a natural log, it's going to be 1 over and then whatever is inside the natural log. So it's going to be x plus 25 under 1 when you differentiate this natural log of x plus 25. Move this 3 into the numerator, so it's going to be 3 over x plus 25. So this is dy over dx, so sub in x is equal to 0, so it's going to be 3 over 0 plus 25, which is equal to 25 under 3. So this is going to be the gradient of the curve at this point P, so therefore this is going to be the gradient of the tangent as well. So therefore we've got the gradient and we've got the coordinates of the point P, so we can use this for the equation of the tangent. So we can use this equation here. So it's going to be y minus y1, so it's going to be y minus, and the y coordinate is 3 natural log of 25, and this is equal to the gradient, which is this 25 under 3, and then it's going to be x minus x1. Now, as the x coordinate that we're using is 0, it's going to be x minus 0, so we can just write this as x like this here. We need to get it into this format here, where a, b, and c are integers. So if we get rid of this 25 denominator by multiplying everything through by 25, it's going to be 25y minus 75 natural log of 25 is equal to 3x. Now for this equation, we need to get the x and y terms onto the same side. So if we move this 25y onto the other side, we get minus 75 natural log of 25 is equal to 3x minus 25y. And if we get rid of this minus here by multiplying everything through by minus 1, we get that it's going to be 25y minus 3x is equal to 75 natural log of 25. Okay, now this isn't the final answer because we've got this part here, which is fine. We've got these y and x terms onto the same side, but we need this to be equal to c natural log of 5, where c is an integer. Now we've got an integer here, this 75, but this is not the natural log of 5, this is the natural log of 25. So how do we deal with this? Okay, so the natural log of 25, remember that 25 is 5 squared, okay? And remember, we can bring this 2 to the front here, so this is going to be equal to 2 natural log of 5. So we have this natural log of 5 that we want here. So if we sub this in here, it's going to be 25y minus 3x is equal to 75 times, and then instead of this natural log of 25, we can sub in this 2 natural log of 5. So this is going to be 25y minus 3x is equal to 150 natural log of 5, and this here is the final answer. This is in this format here where a, b, and c are integers. In terms of the marks here, you get 1 mark for figuring out that the y coordinate for P is 3 natural log of 25. You get another mark for finding dy over dx and subbing in 0 like this here. You get another mark for using the equation of a straight line here, and you get the final mark for getting the final answer. Okay, so for question 10, we're told that f of x is equal to 3kx minus 18 over x plus 4 x minus 2, where k is a positive constant. And for part A, we need to express f of x in partial fractions in terms of k for 3 marks. So this is obviously a partial fractions question, okay? So to split this up into partial fractions, so this 3kx minus 18 over x plus 4x minus 2. We're going to split this up into 2 partial fractions. One of them is going to have this denominator of x plus 4, and the other one is going to have the denominator of the x minus 2. We're going to call this numerator a and this numerator b, and we're going to find what a and b are. Okay, so the first step is we're going to multiply everything in this equation here by this denominator, x plus 4, x minus 2. So we're going to multiply everything by x plus 4 x minus 2. So if we do this, so firstly on this side of the equation, the denominator will cancel out and just leave us with 3kx minus 18. And then with this term here, this x plus 4 denominator will cancel out this x plus 4 bracket to leave us with a multiplied by x minus 2. So it's a x minus 2. And then it's going to be plus, and then this x minus 2 denominator will cancel out this x minus 2 bracket to leave us with b multiplied by x plus 4. So this is bx plus 4. Now I'm going to solve this via substitution because I think it's easier. So let's first sub in. So for this bracket here, let's sub in, let x equal 2. If we do this, this will be equal to 0, so this a term will cancel out. So we're just going to be left with 3k, and then instead of x, it's going to be 2 minus 18. This is equal to b, and then it's going to be 2 plus 4, like this here. So 3 times 2 is 6. This is going to be 6k minus 18, and this is going to be equal to 6b, and divide both sides by 6, so we get that b is equal to k minus 3, okay? And then if we focus on this bracket here, this x plus 4, so if we let x equal minus 4, so this b term will go away as x plus 4 be equal to 0, so it's going to be 3k minus 4 minus 18 is equal to a, and then it's going to be minus 4 minus 2. So 3 times minus 4 is going to be minus 12. So it's going to be minus 12k minus 18 is equal to minus 6a. And then divide both sides by minus 6. So we get a is equal to 2k plus 3. So therefore, if we sub this in to this up here, we're going to get that 3k x minus 18 over x plus 4x minus 2 is equivalent to x plus 4 under a, which is this 2k plus 3, plus x minus 2 under b here, which is k minus 3, and then this is the answer. In terms of the marks here, you get 1 mark for getting this line here. You get another mark for making these substitutions and attempting to find A and B, and you get another mark for getting the final answer. Okay, and then for part B, we need to find the exact value of k for which the integral between minus 3 and 1 of f of x is equal to 21 for 4 marks. So this is a question on integrating using partial fractions. The reason for this is so f of x is equal to this up here, but we cannot directly integrate this. However, because we showed in part A that we can split this up into these two partial fractions, we can directly integrate this. So what we're going to do, we're going to rewrite this question here as the integral between minus 3 and 1 of these partial fractions, so x plus 4 under 2x plus 3 plus x minus 2 under k minus 3 dx, and then this is equal to 21, and we're going to do this integral and find what k is. Okay, so if we do this, so let's integrate these two terms individually. So if we start with this one here, let's take this 2k plus 3 as it's a constant. Let's take this out of the integral, so it's going to be 2k plus 3, and then the integral of x plus 4 under 1 dx. Okay, so this is a lot simpler to deal with. We've taken this out of the integral, so we have to integrate 1 over x plus 4. Okay, to integrate this, remember when you're integrating 1 over something, it's equal to the natural log. So therefore, if we integrate this, this is just year 2 integration. We're still going to have this 2k plus 3 at the front, and then it's going to be the natural log of this x plus 4, but remember it's going to be the modulus of this x plus 4. And then if we focus on this one here, it's the exact same thing. So take the k minus 3 out, so it's going to be the integral of x minus 2 under 1 dx. This is going to be equal to, so we're still going to have the k minus 3 at the front, and then if we integrate 1 over x minus 2, it's going to be the natural log of the modulus of x minus 2. So if we add these terms together, it's going to be 2k plus 3, then the natural log of x plus 4, and then plus k minus 3, and then the natural log of x minus 2, and then you can add the plus c on the end if you want to. So now we're going to sub in the limits of 1 and minus 3, and this is going to be equal to 21. So if we do this, so it's going to be, so if we sub in 1 first, it's going to be 2k plus 3, and then the natural log. So if we sub in 1 for this here, it's going to be 1 plus 4, so it's going to be 5. So it's going to be the natural log of 5 plus k minus 3, and then the natural log of, so if we sub in 1 here, it's going to be 1 minus 2, so it's going to be minus 1, but it's the modulus of minus 1, so it's going to be 1, so this is going to be the natural log of 1, and then this is going to be minus, and then it's going to be this 2k plus 3, and then the natural log, and if we sub in minus 3 into this here, it's going to be minus 3 plus 4, which is going to be 1. This is going to be the natural log of 1, and then it's plus k minus 3, and then the natural log. So if we sub in minus 3 here, it's going to be minus 3 minus 2, which is minus 5, so it's going to be the modulus of minus 5, which is 5, like this here. Okay, so we can do some simplifying with this here, because this natural log of 1 here, natural log of 1 is 0, so this will cancel out, and the same with this here, natural log of 1 is equal to 0. So therefore this is going to simplify down to 2k plus 3 natural log of 5. Remember, we have a minus here, so this is going to be minus k minus 3 natural log of 5, and this is equal to 21. And we're going to rearrange this here in order to find k. So we have this equation here. So firstly, we have natural log of 5 in both of these terms here. So we're going to divide both sides of this equation by the natural log of 5. So we're left with 2k plus 3. Now if we expand this bracket here, so we have this minus k minus 3, it's going to be minus k plus 3, like this here, and then this is going to be equal to 21 divided by the natural log of 5, like this here. 2k minus k is k, and then 3 plus 3 is 6, and this is equal to 21 over the natural log of 5, and then if we take away 6 from both sides, we'll get that k is equal to 21 over the natural log of 5 minus 6, and this here is the value of k. Okay, so this is worth 4 marks. You get 2 marks for integrating it into this format here. You get another mark for getting it into this format, and you get another mark for getting k equal to this. Okay, so here's question 11. It's quite a long question, so I've shown you the entire thing here. Now, for this particular question, I'm not going to go through this in loads and loads of detail, this question, because I made a video entirely dedicated to this question really recently. I called it the hardest question in A-level maths. Not necessarily because this particular question is the hardest question in A-level maths, but I think this type of question, where you use differential equations in a modelling scenario, in my opinion, I really struggled with that at A-level, and I think it's the hardest type of question that you can be asked. So if you kind of want a full method and a full kind of explanation of how these questions work and how to approach them, I'd go back to that video. In this particular video though, I'm just going to go quickly through the answer. So for part A, so we're given this diagram here, and we're told it's a tank in the shape of a cuboid and it's being filled with water. The base of the tank measures 20 by 10 as we can see, and the height of the tank is 5 meters as shown. And at time t minutes after water started flowing into the tank, the height of the water was h meters and the volume of water in the tank was v meters cubed. And we are told that the rate of change of v is inversely proportional to the square root of h, and for part A we need to show that dh over dt is equal to lambda over root h, where lambda is a constant, for 3 marks. Okay, so the way that we do this is we need to make our own differential equations. So let's start with the fact that the volume of water in the tank is v meters cubed. So this grey cuboid here is the water in the tank. Now remember, the volume of a cuboid is equal to the length times the width times the height of the cuboid. Well, here we can see for this water, the length is 20, the width is 10, and the height is this h here. So we can say that the volume of water, which is V, is equal to 20 times 10 times h, so therefore V is equal to 200 h. So what we can do with this v is equal to 200 h, we can differentiate this. So we can differentiate it, so it's dv over dh, and if we differentiate this, this is going to be 200. So we have one differential equation here, that dv over dh is equal to 200, and we can make another differential equation by using the fact that the rate of change of v is inversely proportional to the square root of h. So it says the rate of change of v, so if it's talking about the rate of change of v, this is dv over dt. Okay, it's inversely proportional. Now remember what inversely proportional means. So we have this proportional sign here, if something is inversely proportional, it's proportional to 1 over whatever it's talking about. That's what inversely proportional means. And it's inversely proportional to the square root of h. So it's inversely proportional to the square root of h. So dv over dt is proportional to 1 over root h. What we can do with this is we can write this as an equation by saying dv over dt. Whenever you have a proportional sign like this here, you can replace it with an equal sign and a k constant. So we can say that this is equal to, and if we move the k into the numerator, we can say that this is equal to k over root h, like this here. So we have another differential equation here, that dv over dt is equal to k over root h. Now, as the final answer, we need dh over dt, which is not what we have here. So we need dh over dt. Now, the way that we can do this is by multiplying these two differential equations together. Remember, when you multiply differential equations together, they sort of work like fractions. So if we're multiplying these two differential equations together, we want dh to be in the numerator here, and we want dt to be in the denominator here. If you look at both these differential equations, we have this dv term that we don't want in the final answer of the dh over dt. So let's make this the denominator here and this the numerator here. So if we multiply these two fractions together, this dv will cancel out with this dv and just leave us with dh over dt. Okay, we have dv over dt here, this k over root h. We don't have dh over dv, we have dv over dh. Now remember that dh over dv is equal to 1 divided by dv over dh. So therefore dh over dv is equal to 1 divided by dv over dh, which is 200. So therefore this is equal to 1 over 200. So therefore dh over dt is equal to dh over dv, which is this 1 over 200, multiplied by dv over dt, which is this k over root h. If we bring this 1 over 200 into the numerator, so it becomes k over 200 over root h. If we look at what we need for the final answer, we need this lambda constant in the numerator. So if we say that lambda is equal to k over 200, we can say that dh over dt is equal to lambda over root h, which is what's required. This is worth 3 marks. In order to get the 3 marks here, you get 1 mark for getting that dh over dv is equal to 1 over 200. You get another mark for doing this here, and then you get another mark for getting the final answer. Okay, and then for part B, we're given these two bullet points here, that initially the height of the water in the tank was 1.44 meters, and exactly 8 minutes after water started flowing into the tank, the height of the water was 3.24 meters. And we need to use the model to find an equation linking h with t, giving our answer in this format here, where a and b are constants to be found, and this is for 5 marks. Okay, so what we need to do is we need to solve this differential equation here, and we need to get it into this format here. So we need to integrate this. Okay, so I did a video on solving differential equations. So this dh over dt is equal to lambda over root h. The way that we're going to solve this is, so firstly we're going to get all the h and dh terms onto this side of the equation, and all of the t and dt terms onto this side of the equation. So firstly, let's multiply everything in this equation by this root h to get rid of this denominator. So it becomes root h dh over dt is equal to lambda, and then let's get rid of this dt denominator, if you like, by multiplying everything through by dt. So this becomes root h dh is equal to lambda dt, like this here. Okay, so now we need to integrate this. So on this side it's going to be the integral. Now this root h, I'm going to write this as h to the power of a half because this is easier to integrate, and then dh, and then this is equal to the integral of lambda dt. Okay, if we integrate this, so if we integrate h to the power of a half, this is just year 1 differentiation, so this power is going to go up to 3 over 2, and then we're going to divide by it, so it's going to be 2 over 3 h to the power of 3 over 2 like this here, and then this is equal to, so lambda is just a constant, so if we integrate it in terms of t, it's going to be lambda t like this here, and then remember the plus c on the end. So now we need to find this lambda and this plus c here. So what we're going to do, we're going to use these two bullet points here in order to do this. So we are told that initially the height of the water in the tank was 1.44 meters. Whenever you see the word initially, this means that t is equal to 0, and we're told initially the height of the water in the tank was 1.44 meters, so therefore here h is equal to 1.44. And then if we focus on the second bullet point, so we're told exactly 8 minutes after water started flowing into the tank, so as we're told that t is in minutes, therefore here t is equal to 8, and then the height of the water was 3.24 meters, so therefore h is equal to 3.24. So essentially we kind of have two coordinates, if you like, that we can sub into this equation that we have down here, and then we can find the constants lambda and plus c. Okay, so if we start with the t is equal to 0, h is equal to 1.44. So if we sub this in, it's going to be 2 over 3, and instead of h, it's going to be this 1.44. So the power of 3 over 2 is equal to lambda, and instead of t, it's going to be 0 like this here, and then plus c. So lambda multiplied by 0, this will just cancel out. So therefore it's going to be this here, which if you put this into a calculator is equal to 144 over 125, and this here is just equal to c. So therefore c is equal to 144 over 125. So therefore we can sub this in. So this equation is now 2 over 3 h to the power of 3 over 2 is equal to lambda t plus 144 over 125. So now we can sub in this point here. So this is t is equal to 8 and h is equal to 3.24. So this is 2 over 3, and instead of h is this 3.24 to the power of 3 over 2 is equal to lambda times t, so t is 8, so this is going to be 8 lambda plus 144 over 125. So this here, if you put this into your calculator, it's equal to 486 over 125, and this is equal to 8 lambda plus 144 over 125. Move this 144 over 125 onto the other side of the equation, so we get that 324 over 125 is equal to 8 lambda, and then divide both sides by 8, so we get that lambda is equal to 171 over 500. So if we sub this into the equation for lambda, this is now going to be 2 over 3h to the power of 3 over 2 is equal to 171 over 500t plus 144 over 125. Now, if you look at the final answer, we need it in this format here. Now you can see that we have h to the power of 3 over 2 on this side here, but at the moment we have this 2 over 3 in front of it, so we need to divide everything in this equation by 2 over 3. So if we do this on this side, it's now going to be h to the power of 3 over 2 on its own. This 171 over 500 divided by 2 over 3, if you put it into a calculator, is equal to 513 over 1000, and then t, and then plus, and then if you divide 144 over 125, if you divide this by 2 over 3, it's equal to 216 over 125, and this here is the final answer where we found A and B. In order to get the marks here, you get 2 marks for integrating it into this format here, you get another mark for finding C, you get another mark for finding lambda, and you get a final mark for getting it into this format here. Okay, and then for part C, we need to find the time taken from when water started flowing into the tank for the tank to be completely full for 2 marks. Okay, so if we look at the diagram, we can see that the height of this tank is 5 meters. Now remember, h is the height of the water inside the tank. So in order for the tank to be completely filled with water, h needs to be equal to 5. And then what we're just going to do, we're going to sub in h is equal to 5 into this equation here, and then find the value of t, and this is going to be the time taken for this to happen. So if we do this, it's going to be 5 to the power of 3 over 2 is equal to 513 over 1000t plus 216 over 125. Now 5 to the power of 3 over 2, if you put this into your calculator, is equal to 11.18, and this is 513 over 1000t plus 216 over 125. Move this 216 over 125 onto the other side, so it becomes 9.45 is equal to 513 over 1000t, and then divide both sides by 513 over 1000 to get that t is equal to 18.42 minutes. So it takes 18.42 minutes for water to completely fill the tank. In order to get the 2 marks here, you get 1 mark for subbing in this 5 for h and trying to rearrange in order to find t, and you get the other mark for getting that t is equal to 18.42. Okay, so here's question 12 here. This is quite a long question, so I've shown you the entire thing here. And then for part A, so we're given this graph here, and we're told that it's about the number of subscribers to 2 different music streaming companies. This is being monitored here. And the number of subscribers to company A, which is NA, and this is in thousands, is given by this function here, which is a modulus. And the number of subscribers to company B in thousands is NB, and it's given by this modulus equation here. And this is a sketch of the 2 graphs, okay? And for part A, we need to find the initial difference between the number of subscribers to company A and the number of subscribers to company B for 2 marks. So this is a modulus question. We did a video on modulus questions like this. So the way that we do this is initial. Remember, whenever you see the word initial, this is where t is equal to 0. So essentially we're just going to sub in t is equal to 0 into this equation for NA and NB, and then find the difference between these 2 numbers. So if we do this, so if we start with NA, so NA is the modulus of t, now t is 0 here, and then minus 3, and then plus 4, okay? So this here is going to be the modulus of minus 3, so this is going to be 3, so it's going to be 3 plus 4, which is 7. So NA is equal to 7, and NB is equal to 8 minus the modulus of 2t, so it's going to be 2 times 0, and then minus 6. So this 2 times 0 is just going to be 0, so it's going to be the modulus of minus 6, which is 6, so it's going to be 8 minus 6, which is 2. So the difference NA minus NB is equal to 7 minus 2, which is equal to 5. Now remember, NA and NB are both in thousands, so the NA minus NB is equal to 5. This means that the total number of subscribers difference is going to be 5,000, like this here. This is worth 2 marks. In order to get the 2 marks, you get 1 mark for figuring out that this is 7 and this is 2, and you get another mark for getting this as 5,000. Okay, and then for part B, we're told when T is equal to capital T, company A reduced its subscription prices and the number of subscribers increased. And we need to suggest a value for capital T, giving a reason for our answer for 2 marks, okay? So if we look, so we're talking about company A here, so we're talking about NA, so we're talking about this line here, okay? So this capital T, this is where company A reduced its subscription prices and the number of subscribers increased. So if we look at this line, we can see that this line is decreasing, so the number of subscribers is decreasing, and then it hits this point here and then it starts increasing. So this here is the point that they're talking about, where after this the number of subscribers increased, so therefore this here is capital T, okay? So we need to find this point here. Now, this is kind of the turning point of this modulus. This is where it kind of reflects itself. Now, if you remember a feature of moduluses, this point exists where the function inside the modulus is equal to 0, because this is kind of where it flips its sign. So before this is negative, and then after this is positive, or vice versa. The point being is the sign changes, and this is kind of where you get this modulus, because you have the modulus where it goes from positive to negative. The graph kind of reflects like this. So this is where t minus 3 is equal to 0, because this is the function inside the modulus, so therefore t is equal to 3, so therefore capital T is equal to 3. It says it wants you to give a reason for your answer. Well, as we said, this is kind of the turning point of this modulus, and after this we can see that the line goes up. So we can say something like this is because after this point NA increases. Something like that will give you the mark. That's a valid reason. So therefore you get the 2 marks here, you get 1 mark for finding t is equal to 3, and you get another mark for giving a reason like this. Okay, and then for part C, we need to find the range of values of t for which NA is bigger than NB, giving your answer in set notation for 5 marks. So if we look at the figure here, so NA is this line here, and NB is this line here. So the sections where NA is bigger than NB are here and here. So we need to find these sections, and the easiest way to do this is we can see that these two lines have 2 points of intersection. They have one here and one here. This section is before this point of intersection, and this section is after this point of intersection. So what we just need to do is find these points of intersection. So these are the two equations for NA and NB. So the points of intersection occur when these two are equal to each other. So it's when the modulus of t minus 3 plus 4 is equal to 8 minus, and then the modulus of 2t minus 6. And we need to solve for t. Okay, so there's a few ways that you can solve this question. The easiest way to do it, in my opinion, is if you look at this figure here. So as their moduluses, we have these kind of 2 turning points where the graph reflects on themselves. And as we talked about in part B, this is where the function inside the moduluses are equal to 0. And you can actually see that for both these points, they are the same t value, and we found out in part B that this is where this is 3 here. So around this point here where t is equal to 3, the sign changes for the function inside the modulus. So for example, for the t minus 3, for example, the function inside this modulus, before 3, so this side here, the function will be negative, and after 3, so this side here, the function will be positive, or vice versa, the sign will change. And what we're going to do is we're going to figure out which way around this is. So if we start with the NA is equal to the modulus of t minus 3 plus 4, so if we first focus on this side of the equation, so this here is where t is less than 3. So the function inside this modulus, so t minus 3, so let's say that t is less than 3, so let's say something like t is equal to 2, so it's going to be 2 minus 3, which is minus 1, so therefore t minus 3 is going to be negative. So on this side of the equation, t minus 3 is negative, so on this side we're going to say that NA, the function inside the modulus of NA, is negative, and therefore as the sign flips on this side, the function inside the modulus of NA is going to be positive, because this is where it's going to be t is more than 3, so therefore t minus 3, if it's something like 4 for example, it's going to be 4 minus 3, which is 1, so it's now going to be positive. If we now focus on NB, so this is 8 minus the modulus of 2t minus 6, so if we first focus on this side here, so this is where t is less than 3, so this 2t minus 6, let's say that t is something like t is equal to 2, so it's going to be 2 times 2, which is 4, and then minus 6, which is minus 2. So on this side where t is less than 3, this function is negative, so therefore here we're going to say that NB, the function inside the modulus, is negative, so therefore as the sign flips on this side, the function inside the modulus of NB is going to be positive. So we can now use this information in order to find these 2 points of intersection. So for this one here, we know that the functions inside the modulus for both NA and NB are both going to be negative. So therefore we can use this in order to solve this equation, because we know this t minus 3, we know that this is going to be negative, this t minus 3, and then we have this plus 4 here, and this is equal to 8 minus, and we know this 2t minus 6 is going to be negative, so it's going to be minus this 2t minus 6 like this here. So if we expand this here, it's going to be minus t plus 3 plus 4. This is equal to 8, and then we have these two minuses here, so now this is going to be plus, and then 2t minus 6 like this here. This is going to be minus t plus 7, and this is equal to 2t plus 2 like this here. If we bring this 2t onto this side, it's going to be minus 3t, and if we bring this 7 onto this side, it's going to be minus 5, so therefore t is going to be equal to minus 5 divided by minus 3, which is 5 over 3. So this point of intersection here, this is where t is equal to 5 over 3. If we look at this point of intersection here, we know that the functions inside the modulus for both NA and NB are both going to be positive. So therefore we can use this information. So we can say that this here, this t minus 3 is going to be positive, and then it's going to be plus 4. And this is equal to 8 minus, and we know that this 2t minus 6 is going to be positive, like this here. So this here is going to be t, and then it's going to be plus 1 like this here, and this is equal to 8, and if we expand this bracket, it's going to be minus 2t plus 6 like this here. So this is going to be t plus 1 is equal to minus 2t plus 14. If we move this minus 2t onto the other side, it becomes 3t, and if we move this plus 1 onto the other side, it becomes 13. So divide both sides by 3, so we get that t is equal to 13 over 3. So if we look at this here, this is where t is equal to 13 over 3. Now remember that NA is bigger than NB here and here. So this section in purple is before this 5 over 3. So this is where t is less than 5 over 3. And this section here is after this point of intersection. So this is where t is bigger than 13 over 3. So therefore we know now that t is less than 5 over 3, or t is bigger than 13 over 3, and these are the sections for which NA is bigger than NB. It says it wants the answer in set notation. I did a video on set notation. It's very easy. Essentially what you just do is you do open bracket, and then you say t when t is less than 5 over 3, and then close bracket, and then you kind of do the U symbol here to denote or, and then you do open bracket t when t is bigger than 13 over 3, and then close bracket like this here, and this is the final answer in set notation. This is worth 5 marks. In order to get the 5 marks, you get 1 mark for getting this equation here, you get another mark for getting this equation here, you get another mark for getting the correct t values, you get another mark for getting the correct inequalities here with the or, and you get a final mark for writing it in set notation. Okay, and then for part D, we need to state a limitation of the model used for company B for 1 mark. So this is the model used for company B, and it's easier to see this if we look at the diagram. So this is this line here that initially goes up and then it goes down. The big limitation with this model is that if we go beyond the 5 years here, so if we keep going, we can see that this line would keep going down like this here, and there would be nothing that would stop it from becoming negative. It would just keep going on and on and on. So the limitation of this model, it says we need to state a limitation. You can just say something like eventually NB would become negative, which is impossible because obviously you can't have a negative number of subscribers, and that there would give you the mark. Okay, so here's question 13, and for part A, we need to find the first three terms in ascending powers of x of the binomial expansion of 3 plus x to the power of minus 2, writing each term in its simplest form for 4 marks. Okay, so this is a year 2 binomial expansion question because we have this power of minus 2 here. Now, I've given you the formula here for the binomial expansion of 1 plus x to the power of n because this is given to you in the formula booklet, so we need to use this here. So at the moment, we have this 3 plus x to the power of minus 2. Now, this is not in this format here, because here we need a 1, but at the moment we have a 3 here. So what we're going to do is we're going to factorize out the 3 from this. So if we do this, so it would be 3, and if we factorize out 3 from 3 plus x, it's now going to be 1 plus x over 3, like this here. Remember, all of this is to the power of minus 2, including this 3 here, and then we can simplify this because 3 to the power of minus 2 is equal to 1 over 9. So this is going to be 1 over 9, 1 plus x over 3 to the power of minus 2. And now we can use this formula here on this 1 plus x over 3 to the power of minus 2 because we have this 1 here. So if we do this, remember we need to multiply this entire thing when we're expanding it by 1 over 9. So this is going to be 1 over 9 at the front here, and then if we use this 1 plus x over 3 to the power of minus 2, this 1 over x, 1 plus x to the power of n, so it's going to be equal to 1 here, and then plus nx, so n is minus 2, so it's going to be minus 2 here, and then x, so remember our x here is this x over 3, so it's going to be x over 3 like this here, and then plus n, so n is minus 2, and then n minus 1, so minus 2 minus 1 over 2 times 1, which is just 2, and then it's x squared here, so this is going to be the x over 3 squared, and it says we only need the first 3 terms, so these are going to be the first 3 terms here. Remember, this entire thing is multiplied by 1 over 9, so we can simplify this. So we still have this 1 over 9 at the front here, we're still going to have this 1, and then minus 2 multiplied by x over 3 is going to be minus 2 over 3x like this here, and then this is plus, so minus 2 times minus 2 minus 1, so this is going to be minus 3, it's going to be minus 2 times minus 3, which is 6, and then 6 divided by 2 is going to be 3, and then this is multiplied by x over 3 squared, so this is going to be x squared over 9 like this here. We can do some more simplifying on this, so this is going to be equal to 1 over 9, and then this 1 minus 2 over 3x, and then plus, and then 3 times this x squared over 9 is going to be this x squared over 3 like this here, and then if we expand this bracket, so we expand everything by this 1 over 9. It's going to be 1 over 9, and then it's going to be minus 2 over 27 x, and then this is going to be plus, and then this denominator of this 9 times 3 is going to be 27. So it's going to be 27 under 1 of this x squared here, and then this is the final answer. This is the first 3 terms of this expansion. This question is worth 4 marks. You get 1 mark for factorising the 3 out like this. You get 2 marks for this line here using the expansion, and you get 1 mark for the final answer. Okay, and then for part B, we need to use the answer to part A, and using algebraic integration, we need to estimate the value of the integral between 0.2 and 0.4 of 6x over 3 plus x squared, giving your answer to 4 significant figures for 4 marks. Okay, so as it's telling us to use part A, we're going to want to use this 3 plus x to the power of minus 2. We're going to want to get this into this integral. So if we look at this 6x over 3 plus x squared, you can see we have this 3 plus x to the power of 2. Remember, when you have something in the denominator, you can bring it into the numerator by adding a minus power. So what we can do, we can rewrite this integral here as the integral between 0.2 and 0.4 of 6x, and then this is multiplied by this 3 plus x denominator, but now instead of to the power of 2, it's going to be to the power of minus 2, like this here. So now you can see we have this 3 plus x to the power of minus 2, which is what we have here. So as we're estimating the value, and as we did the binomial expansion of the first 3 terms of this 3 plus x to the power of minus 2, what we can do is we can sub these terms in order to get an approximation for this integral. So what we can do is we can say that this integral is approximately equal to the integral between 0.2 and 0.4 of 6x, and then instead of this 3 plus x to the power of minus 2, we're going to write these 3 terms here. So it's going to be 1 over 9 minus 2 over 27x plus 27 under 1 x squared, and then dx, like this here, and then this here we are going to integrate. Okay, so let's ignore these limits for now. So let's first focus on integrating this 6x multiplied by these 3 terms here. So if we expand this bracket, it's going to be 6x multiplied by 1 over 9, which is going to be 2 over 3 x, like this here, and then it's going to be 6 multiplied by this 2 over 27, which is going to be equal to minus 4 over 9 x squared. If you figure it out, because remember we've got an x here and an x here, then this is going to be plus, and then this 6x multiplied by this 1 over 27 x squared is going to be equal to 2 over 9 x cubed, so like this here, and then we have this dx. So if we integrate this here, this is just year 1 integration. So if we integrate this, it's going to be 2 over 3 multiplied by, and then if you integrate x, it's equal to half x squared, and then minus 4 over 9, and then if you integrate x squared, it's equal to 1 over 3 x cubed, and then plus 2 over 9, and if you integrate x to the power of 3, it's equal to 1 over 4 x to the power of 4, and then we have this plus c on the end, and then we can simplify this. So we have this 2 over 3 multiplied by this half, which is going to be equal to 1 over 3, and then x squared, and then we have this minus 4 over 9 multiplied by this 1 over 3. This 9 times 3 is going to be 27, so this is going to be 27 under 4 x to the power of 3, like this here, and then it's plus this 2 over 9 multiplied by this 1 over 4, which is going to be equal to 1 over 18, and then this x to the power of 4, and then remember this plus c, like this here. So now we're going to plug in the limits of 0.4 and 0.2. So if we do this, so it's going to be 1 over 3, and instead of x here, it's going to be 0.4 squared, and then minus 27 under 4 of this 0.4 to the power of 3 plus 1 over 18, 0.4 to the power of 4, and then it's going to be minus, and then we're going to sub in the 0.2, so it's going to be 1 over 3, 0.2 squared minus 4 over 27, 0.2 cubed plus 1 over 18, 0.2 to the power of 4, like this here. And then this here, if you put this into your calculator, it says it wants it to 4 significant figures. If you put this into your calculator, it's equal to 0.03304 to 4 significant figures, and then this here is the final answer. This is worth 4 marks. In order to get the 4 marks, you get 1 mark for getting it into this format here, you get another mark for integrating it into this format, you get another mark for subbing in the 0.4 and 0.2, and you get another mark for getting this final answer here. Okay, and then for part C, we need to find, using algebraic integration, the exact value of this integral here that we talked about in part B, giving our answer in the form a natural log of b plus c, and this is for 5 marks. Now, this integral here, there is actually quite a few ways that you can approach this one. The way that I'm going to do it is via substitution, because I think that's the easiest and the one that makes most sense. However, I think an equally valid way is to do it by parts, if you write it as the integral of 6x and then 3 plus x to the power of -2 like this here. You can integrate this by parts. You could also do this via partial fractions. I personally wouldn't do it that way. I don't think that feels that natural. But if you're really good with partial fractions, you can do it that way as well. But I'm going to do this via substitution. So if we look at this here, so we have this 3 plus x in the denominator, which is kind of the complicated thing that we're dealing with. So if we say that u is equal to 3 plus x, we can rewrite this integral here. I'm going to ignore the limits for now. We can rewrite this integral as, so 3 plus x is now u, so it's going to be u squared in the denominator, and this is under 6x, and then it's dx like this here. So we need to get rid of this 6x here. So the way that we can do this is if we say, so u is equal to 3 plus x. If we move the 3 to the other side, so u minus 3 is equal to x, and if we multiply both sides by 6, we get that 6u minus 18 is equal to 6x. So therefore we can rewrite this integral here as the integral, instead of 6x, it's this 6u minus 18, and this is over u squared, and then dx. Now we need to get rid of this dx here for a du. So if we look at this, u is equal to 3 plus x. If we differentiate this, it's going to be du over dx is equal to, so 3 is just a constant, so it goes away, and if you differentiate x, it's 1. So therefore du is equal to dx, so therefore we can do a straight swap the dx to the du. So we can write this as the integral of 6u minus 18 over u squared, and then du here, and this we can integrate. Okay, so if we integrate this here, so if we split up, so we have two terms in the numerator here and one term in the denominator. So if we split up this fraction, it's going to be 6u over u squared minus 18 over u squared like this here, and then du, and then we can simplify this further. So this will be the integral. So 6u divided by u squared is going to be 6 over u like this here, and then this is going to be minus this 18 over u squared, and then du. So if we integrate this, so let's consider these two terms individually. So if we start with the 6 over u, I'm going to take the 6 out of this integral, so it's going to be 6 and then the integral of 1 over u like this here. Remember, when you integrate 1 over u, du, something like this here, it's going to be equal to, so we're still going to have the 6 at the front here, and then when we integrate this, this is year 2 integration, this is going to be the natural log of the modulus of u, like this here. So if we focus on this minus 18 over u squared, again, I'm going to take this minus 18 out of the integral here, and then it's the integral of this 1 over u squared. I'm going to rewrite this as u to the power of minus 2 because this is easier to integrate. So this is going to be equal to minus 18 multiplied by, and if you integrate u to the power of minus 2, this is just year 1 integration, this minus 2 power will go up by 1 to minus 1, so it's going to be minus u to the power of minus 1 like this here, and then minus 18 times this minus 1 here is going to be 18, because this minus will cancel out this minus, so it's going to be 18 and then u to the power of minus 1, which we can rewrite as 18 over u like this here. So therefore this integral is going to be these two terms added together, so it's going to be 6 and then the natural log of the modulus of u plus 18 over u, and then you can add the plus c if you want to as well. So now what we need to do is we need to plug in the limits of 0.4 and 0.2. Now remember, when you're integrating via substitution, there are two ways that you can plug in the limits. Either one, you can sub back in this 3 plus x for the u terms here, or you can change the limits in terms of u. I'm going to quickly change the limits in terms of u. So we have here, we have that u is equal to 3 plus x. So if we focus on the first limit, which is, if we focus on the upper limit, which is 0.4, this is going to be u is equal to 3 plus 0.4, which is going to be equal to 3.4. So that means that the limit which was 0.4 when we were working in terms of x, if we're working in terms of u, is now going to be 3.4. And then if we look at the lower limit, which is the 0.2, so it's going to be u is equal to 3 plus 0.2, 2, which is equal to 3.2. So therefore, the lower limit is no longer going to be 0.2, it's going to be 3.2 if we're working in terms of u. So the upper limit is 3.4 and the lower limit is 3.2 when we're working in terms of u. So if we sub these limits in, it's going to be 6 and then the natural log of the modulus of 3.4. We don't need to write the modulus anymore. Let's write it as 3.4 like this here, and then plus 18 over 3.4, and then minus, and then it's going to be 6, and then the natural log of u, which is 3.2, and then plus 18 over 3.2 like this here. So we can simplify this. So we're still going to have 6 natural log of 3.4 here, and then it's plus, and then 18 over 3.4 is equal to 90 over 17 if you put this into your calculator, and then it's going to be, if we expand this bracket, minus 6 natural log of 3.2, and then it's going to be minus this 18 over 3.2, which if you put it into your calculator is equal to 45 over 8, and we can simplify this further. So here we have this 6 natural log of 3.4 minus 6 natural log of 3.2. Now remember, if the coefficients of the logs are the same and you have a log minus another log, you can combine these logs by dividing what is inside the log. So we can rewrite this as 6 natural log. We have this natural log of 3.4 minus the natural log of 3.2, so we can rewrite this as 3.4 divided by 3.2 like this here, and then we've got this 90 over 17 minus 45 over 8, which if you put into your calculator is equal to minus 45 over 136, and then we can simplify this further because we've got the 6 natural log, and then 3.4 divided by 3.2 is equal to 17 over 16, and then minus 45 over 136, and this here is the final answer where we've got it in the format of the a natural log of b plus c. Okay, so this question is worth 5 marks. Now, obviously, you'll get different marks for different methods that you use, whether you use integration by substitution, integration by parts, or partial fractions. If you use integration by substitution, you get 1 mark for making some sort of substitution. You get another mark for getting it into this format here. You get another mark for integrating it correctly into this format. You get another mark for subbing in the correct limits, and you get another mark for getting the correct final answer. Okay, so for question 14 for part A, we need to show that this equation here may be written as sin 2 theta a cos squared theta plus b cos theta plus c is equal to 0, where a, b and c are constants for 3 marks. So this is a trigonometric identities and equations question. And one thing that I would really advise with these questions is, rather than just randomly going at this and trying to simplify it, look at what you want for the final answer and try and work towards this. One of the reasons I say this is, if you look at this equation here, one of the first things you might be tempted to do is to use the double angle formula on this sin 2 theta. However, when you look at the final answer, you can see that we actually want this sin 2 theta in the final answer, so it makes sense to not touch this sin 2 theta and keep it as it is at the moment. When we look at this equation here, there are 2 things that we don't want in this final answer. We don't want these tan thetas, and we don't want this sin squared theta here. We only want sin 2 theta here and these cos theta functions. So in order to simplify this, let's write this. So let's keep this as 2 tan theta for now, and then it's going to be 8 cos theta. Now remember, we don't want sin squared theta in this final answer, so this is a sign that we can use the trigonometric identity that sin squared theta plus cos squared theta is equivalent to 1. So if we move the cos squared theta onto the other side, we get sin squared theta is equivalent to 1 minus cos squared theta. So we can sub this in here, so we can write this as plus 23, and then instead of sin squared theta, it's 1 minus cos squared theta like this here, and this is equal to 8 sin 2 theta. Now we have this 1 plus tan squared theta that we don't want in the final answer. Now we could use a trigonometric identity here because we've got this 1 plus tan squared theta. We could use that 1 plus tan squared theta is equivalent to sec squared theta. Now we don't want sec theta in the final answer either. However, remember that sec squared theta is equivalent to 1 over cos squared theta. Now we do want cos thetas in the final answer, so we could represent it in that form later. So let's sub in this sec squared theta for the 1 plus tan squared theta. So therefore it's going to be 8 sin 2 theta, and instead of this here, it's now going to be sec squared theta like this here. Okay, so we can do some simplifying here. So we have this 2 tan theta, and then it's 8 cos theta, and then if we expand this bracket here, it's going to be plus 23 minus 23 cos squared theta like this here, and this is equal to 8 sin 2 theta sec squared theta. Now we don't want tan theta or sec theta in our final answer here, so let's write this as 2, and then tan theta we can write as sin theta over cos theta, and then this is still going to be this 8 cos theta plus 23 minus 23 cos squared theta, and this is equal to 8 sin 2 theta, and then rather than this sec squared theta, let's write this as cos squared theta under 1 like this here. Now we can see that we have cos theta denominator here and a cos squared theta denominator here. So here, let's multiply both sides of this equation by cos squared theta to get rid of this denominator here. So if we do this, so it's going to be 2, and then this cos theta, because we're multiplying it by cos squared theta, this cos theta denominator is going to go away, but as this is only cos theta, it's not cos squared theta, we're still going to be multiplying by cos theta here. Then it's 8 cos theta plus 23 minus 23 cos squared theta is equal to, and then this cos squared theta is going to cancel out, so we're just going to be left with 8 sin 2 theta on this side. Now we don't want this sin theta, however we have this 2 sin theta cos theta, and remember that sin 2 theta is equivalent to sin theta cos theta, and we want sin 2 theta in our final answer. So let's sub out this 2 sin theta cos theta here for sin 2 theta. So therefore this becomes sin 2 theta, and then it's going to be this 8 cos theta plus 23 minus 23 cos squared theta, and this is equal to 8 sin 2 theta. Now if you look at this equation, we want all of the terms on this side, we want the other side equal to 0. So if we bring this 8 sin 2 theta onto this side of the equation, so it becomes sin 2 theta 8 cos theta plus 23 minus 23 cos squared theta minus 8 sin 2 theta, and this is equal to 0. And then we can factorize out sin 2 theta from both of these terms here, so it becomes sin 2 theta, and then here we're going to be left with the 8 cos theta plus 23 minus 23 cos squared theta. If we sub out sin of 2 theta from this term here, and then it's minus 8 sin 2 theta, so this is just going to be minus 8 like this here, and this is equal to 0. So we can simplify this, so we have this sin 2 theta here. Now I'm going to write this kind of in the quadratic format, so I'm going to write the minus 23 cos squared theta first, and then plus 8 cos theta, and then 23 minus 8 is equal to plus 15, and this is equal to 0. And this here you can have as the final answer here. As we've got this minus coefficient in front of the cos squared theta, it might be a bit easier to just multiply everything here by minus 1. So we get sin 2 theta, 23 cos squared theta minus 8 cos theta minus 15, and this is equal to 0. And this is a bit easier to work with, but either of these answers are fine. So this here is the final answer, where it's in this format here. This is worth 3 marks. To get the 3 marks, you get 1 mark for getting to this line here, and then you get 2 marks for getting this as the final answer. Okay, and then for part B, we need to solve between 360 degrees and 540 degrees for x. This 2 tan x, 8 cos x plus 23 sin squared x is equal to 8 sin 2x, 1 plus tan squared x for 4 marks, where x can't be equal to 450 degrees. So this equation here and this equation here are the exact same thing. The only difference is that instead of theta we have x. And as in part A, we showed that this equation can be written in this format here, or more specifically this format here. We can therefore write this equation as sin 2x 23 cos squared x minus 8 cos x minus 15, and this is equal to 0. And we're going to solve this equation here. As sin 2x multiplied by this bracket here is equal to 0, that means that either sin 2x is equal to 0 or 23 cos squared x minus 8 cos x minus 15 is equal to 0. So we have two equations here that we need to solve. So if we start with this sin 2x is equal to 0. Now at the moment the interval is where x is between 360 degrees and 540 degrees. So 360 degrees and 540 degrees. If we multiply it, because we've got this sin 2x here, we've got this 2x in the trig function. If we multiply everything by 2 here, so this will now be 720 degrees, this will be 2x, and this will be 108. So if we solve now in this interval, because we have 2x, so if we draw a sin graph, so if we draw a quick sin graph between 0 and 180 degrees, so if we say that this is y and this is x, so we're going to say it looks like this here, and then if we say that this is 0, this is 180, this is 360, this is 540, this is 720, this is 900, and this is 1080, like this here. We can see that between 720 and 1080 there are 3 times where the sin graph is 0, which is here, here, and here. So we're going to say that 2x is equal to 720, 900 and 1080. So therefore x, if we divide everything here by 2, is equal to 360, 450 and 540. However, we're told in the question that x cannot be equal to 450 degrees. Just the reason for this is because we have tan x here, and then tan of 450 degrees is undefined. It goes to infinity. So we say that x isn't equal to 450 degrees. So therefore, as x cannot be equal to 450, therefore x is equal to two values, which is 360 and 540. Okay, so now if we focus on this equation here, the 23 cos squared x minus 8 cos x minus 15 is equal to 0. So this here is a trigonometric quadratic. Now you could factorize this, however I think it's just easiest to do this using the quadratic formula. So remember, the quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a, where b is this minus 8, a is 23, and c is minus 15. So therefore here we're going to say that cos x is equal to minus b, so it's going to be minus, and then b is minus 8, so it's going to be minus 8, plus or minus the square root of b squared, which is minus 8 squared, minus 4a, which is 23, and C, which is minus 15, and all of this is over 2a, so 223 like this here. If you put this into your calculator, you get out a value of 1 and minus 15 over 23. So that means that cos x is equal to 1 and cos x is equal to minus 15 over 23. If we focus on the cos x is equal to 1 first, so remember the interval is between 360 and 540, so if we draw a quick cos graph, so if we say this is the y-axis and this is the x-axis, so it's going to look like this here, where we say that this is 0, this is 90, this is 180, this is 270, this is 360, this is 450, and this is 540. Now we're looking for where cos x is equal to 1 between 360 and 540, which we can see is here. So therefore here x is equal to 360 degrees. However, we actually already know this from the sin of 2x is equal to 0, so this one doesn't really matter. Okay, so now let's focus on the cos x is equal to minus 15 over 23. So if we use the same graphs, so if we say that minus 15 over 23 is here, we can see between 360 and 540 there is one solution here. So how do we find this solution? Well, if you put in the inverse cos of minus 15 over 23 into your calculator, you get out a value of 130.7 to 1 decimal place. This is this solution here that your calculator is giving out, but we can use this in order to get this solution here, because as I've talked about before, trigonometric graphs are symmetrical. So what I mean by that is the distance between this solution, which is 130.7, and 90 degrees is going to be 130.7 minus 90, which if you put into your calculator equal to 40.7. This is also going to be the same distance between 450 degrees and this point here. So therefore this point here is going to be 450 plus this 40.7 difference, which if you put into a calculator is equal to 490.7. So therefore this here, x is equal to 490.7 degrees. So therefore there are three solutions to this equation here. They are x is equal to 360 degrees and 540 degrees, which we got up here, and this one here, x is equal to 490.7 degrees. This question is worth 4 marks. To get the 4 marks, you get 1 mark for figuring out that x is equal to 360 and 540. You get another mark for getting that cos x is equal to minus 15 over 23. You get another mark for trying to find the solutions here by using the inverse, and you get the last mark for getting x is equal to 490.7. Okay, so for the final question, question 15, we're told a student attempts to answer the following question, that given that x is an obtuse angle, use algebra to prove by contradiction that sin x minus cos x is bigger than or equal to 1. And the student starts the proof by assuming the opposite, so this sin x minus cos x is less than 1, because they've assuming the opposite here, and then they've squared both sides, so they've got sin x minus cos x squared is less than 1, and then for 3 marks we just need to complete this proof. So this is a proof by contradiction question. So remember that if x is an obtuse angle, this means that x is between 90 degrees and 180 degrees. So we're going to complete this proof here. So we have this sin x minus cos x squared is less than 1. So if we expand this bracket here, so it's going to be sin squared x minus 2 sin x cos x, and then plus cos squared x, and then this is less than 1. I'm going to rewrite this slightly, so it's sin squared x plus cos squared x minus 2 sin x cos x is less than 1. Now sin squared x plus cos squared x is equal to 1, so we can just write this like this here. Then it's minus 2 sin x cos x, and this is less than 1. If we move this 1 to the other side here, so it's going to become minus 2 sin x cos x is less than 1 minus 1, which is 0. Now, if you recall the double angle formula, that 2 sin x cos x is equivalent to sin of 2x, we can sub this in, so we can say that this is minus sin 2x is less than 0, like this here. If we get rid of this minus sign here by multiplying both sides by minus 1, it's going to be sin 2x. Remember, when you multiply or divide by a negative number, you need to flip this inequality sign here. So this is now going to be bigger than 0, like this here. So we have sin 2x is bigger than 0. Now x is between 90 and 180, so x is between 90 and 180 degrees. Now in the trig function here we have 2x. If we multiply everything here by 2, so this will now be 180 degrees, this will be 2x, and this will be 360 degrees. So if we draw a sin graph in this domain here, so this will be y and this will be x, so the sin graph will look like this here, where this is 0, this is 90, this is 180, this is 270, and this is 360. So we're looking at the domain between 180 and 360 degrees, so this is between here and here, and we can see that in this domain the line lies underneath the x-axis, so therefore sin 2x is less than 0. But here we have a contradiction, because here we have shown that sin 2x is more than 0 if we make this assumption here that sin x minus cos x is less than 1. So therefore what we're going to say is, therefore, because we've shown this here, this contradicts the assumption that sin x minus cos x, we assumed up here that sin x minus cos x is less than 1. So therefore, as we have a contradiction, therefore we can say that this is true, this original up here, because we have a contradiction. So therefore we can say that given that x is an obtuse angle, we can say that sin x minus cos x is bigger than or equal to 1, and this here is the proof. This is worth 3 marks. In order to get the 3 marks, you get 1 mark for this line here, and then you get another mark for rearranging it into this format here, and then you get 1 more mark for all this work down here.